Okay, so welcome, and today our team 10 from class uh Artificial Intelligence 16B will talk about our project that we have been doing, which is the e-commerce order manager. First up, let's talk some about us. We built a complete e-commerce order management application that helps business organize their data, streamline daily operations, and make faster, more accurate decisions through a clean, modular, and scalable architecture. Our vision is to build a streamlined system that empowers shop to manage customer products and orders with clarity and accuracy. Our software transforms messy data into clean insights, enabling teams to make a smarter decision and run operation with confidence. Our mission is to deliver scalable, intuitive, and data-driven solutions that streamline operation, strengthen these decision-making, and inspire innovation. We aim to bridge the gap between business process and smart automation, creating tools that help team work faster, collaborate better, and unlock their full potential. Uh, this is the project overview. First off, we'll have the introduction, then the system overview and main features, then the database design and normalization, reporting and data analytics, testing and limitation, and finally is the conclusion. First off, introduction. In the modern retail environment, efficient data management is crucial for business sustainability. Many small businesses still rely on manual record keeping on spreadsheets like, for example, Excel, and leading to data redundancy and inconsistencies. The e-commerce man the e-commerce management system, e-com, is a desktop application developed to solve these problems. It provides a centralized interface for store manager to track customers' products and sales orders using a robust relation database backend. About the system objective, we have this three objective here, which are the primary goals. Uh, and the first one is to data normalization, to transition from unstructured data, which is UNF, to a normalized database schema, free NF to ensure the data integrity. Next is very important, which is the user experience, to provide a user-friendly UI built with Python Tinker library, allowing easy navigation between different management modules. And finally is the business intelligence, to offer real-time insights through a dashboard that visualizes KPIs and revenue trends. Uh, The application is built using a modular architecture. We use the languages which is Python 3.1. GUI framework is Tinker, with TTK for modern styling. Database is MySQL, and data analysis we use Pandas for report generation and data joining. About visualization, we use Matplotlib embedded in Tinker for charts. The system covers four main functional areas: the dashboard, overview of the system metrics, catalog management, the crude operation for products and customers, and the order processing, creating and tracking sales transaction. Reporting is the finally one, which generate detailed sales report using complex joins. Next, let's move on to system overview and the main feature of our system that we have built. Well, as we know, our application e-commerce manager Pro is designed as a complete desktop solution for retail management. It integrates four main components: a dashboard, which is here, a visual product catalog, which is here, an order processing system, and reporting module. Together, these components allow the user to manage store operation in one place. First, the dashboard provides real-time KPIs such as total customer, uh, total orders, total products, and finally is the total revenue of the store. It also includes the revenue charts here, which is here, to shows the top selling products, giving the user immediate business insight the moment they open the app. Second, let's move on to the visual product catalog. The Vision product catalog offers a grid-based product display with images. Each product appears as a card containing its name, price, and picture. As you can see here, we can see the mouse, the keyboard, the laptop stand, and all the stuff. This design makes it easier for staff to browse and, manage product easily instead of scrolling through a text-only list, which will look very confusing. Third is the order processing module. It allows the user to create new orders, add items, select customer, and track order status. The system also validates data such as dates, quantities, and duplicate line items to prevent errors during order entry. And lastly, the reporting feature provides advanced analysis using multi-table joins. User can generate detailed sales report, view export results to CSV. This feature gives the business the ability to examine the performance trends and make informed decisions. Overall, the system overview and key features show how the application combines a clean user interface, a stable backend database, and analytical tools to support daily retail operation efficiently. Now, thank you for listening for my part. I will move on to the next person in my team.
Following this path, I will now move on the data design and normalization process, followed by our reporting and analytics module. Let's start with normalization. The goal here is simple. We want to minimize data redundancy and ensure data integrity. We refine our database schema through a rigorous process, moving from the unnormalized form all the way to the third normal form. We begin with the unnormalized form, or UNF. As you can see in the table 2.1, the data initially look like a flash spreadsheet, and the biggest issue here is the item column. It contains multiple values like a mouse and a keyboard in a single cell. This violates the rule of autonomicity, and it makes the data very difficult to query. To solve this, we move to the first normal form. We expand the list so that every product order combination has its own row, and as shown in the table 2.2. Now every single cell holds a single autonomic value. However, this introduces a new problem, redundancy. You can see that the date and the customer information are repeated for every single item in the same order. Next, we apply the second normal form to remove partial dependency. In our analysis, we see that the product name depends only on the product ID, not the order ID. So we decompose the table into three separate tables: orders, products, and order items. This ensures that non-key attributes depend on the entire primary key. Finally, we reach the third normal form by removing transitive dependency. In the order table, the customer name depends on the customer ID, which is not primary key of the order table. To fix it, we move all customer information into a dedicated customer table. At this stage, our database is fully normalized. Based on that process, here is our final entity relationship diagram. We have four main entities: customers, orders, order item, and products. They are like using primary and foreign keys to ensure relationship and strictly maintained. To implement this design, we established a data dictionary as shown here. This specific schema details such as using virtual phonemes and decimal for price, ensuring consistency across the system. Now that our data structure is solid, let's look at the output. This is the reporting and analysis section. Here is a snapshot of our admin dashboard, specifically looking at the top 10 products by revenue chart. We can derive the three key business insights for 2025. First, the laptop is strictly our best-selling product. Second, the top three products combined account for approximately 16% of our total revenue. This success we should focus our marketing effort here. And third, the bottom products in the list contribute less than 10%, which might indicate a need to review our inventory strategy for those items.
To ensure the reliability of the application, we apply a dual test strategy combining automated unit testing and manual function testing. In this session, we test QLogic using PyTest. Now we will run the test directly in PowerShell. As you can see, I am typing the command PyTest. The machine is executing the test right now, and the results will appear shortly. The test has completed as you can see. All test cases have passed revenue calculation logic and data integrity test. In the revenue calculation logic test, we merge database response such as MOFFAT order item to ensure that the test runs on control data. First, we verify basic case, confirming that revenue is correctly calculated as quantity multiplied by price. Next, we test edge case. For example, when quantity or price is zeros, to ensure the system returns a revenue of zeros without crossing. Finally, we check empty data, meaning that when an order contains no item, the system will return an empty data frame, preventing any user interface error. Regarding data integrity and validation rules, we ensure that only valid status pending, shipped, delivered are accepted, and that any invalid status code are flagged as error. At the same time, we verify temporary consistency, making sure that no order can be recorded with a future date, thereby avoiding logical anomalies in reporting. In addition to automated code tests, we also perform manual verification on the graphic user interface and resource handling. Next, firstly, we check the double renderings. The matplotlib charts correctly update whenever new orders are added. Ensure that the visual representation of data remains accurate and responsive. Next, we verify input constraints. For instance, the ask order from probably direct invalid date formats such as 30 February 2025, preventing incorrect data from being sent to the backend. Finally, we test image for rights handling. We intentionally remove a product image to ensure that the application automatically was the default PNG placeholder instead of crashing or breaking the layout. Despite the successful implementation of the application, the current version does have some limitations that are important to note. First, the system operates in a single-user environment, meaning that no authentication or role-based access control is implemented. This limits its use in a multi-user or enterprise setting. Second, there is local resource dependency. Product image are stored locally, which work for a standalone setup. However, in a distributed system, cloud storage, which would be referred to centuries image across multiple client instances. Third, the system does not handle concurrency. It's like record locking, so in a network environment, rate condition may occur if multiple users attempt to update the same data simultaneously. Finally, reporting is static. The current reports are snap-based, and the GUIs do not support filtering by dynamic data range. This limits the ability to render custom or real-time insight. Overall, while their limitations exist, they provide clear areas for improvement in future versions of the application. The project demonstrates comprehensive application developments from database normalization and architecture design to new implementation, reporting, and software testing. It highlights the importance of data integrity, user experience, and automated validation, while future work could extend features such as authentication, cloud storage, and dynamic reporting. The current system provides a complete and functional solution aligned with professional software standard.